to your email.
Thank you so much. Here.
Thank you. So we can continue with the next presenter. Let me share my screen. So the next presenter is Professor Sanso from Polytechnique Montreal in Canada. She will be presenting her talk on vertical quality of experience evaluation and prediction in large-scale 5G networks. Brunilde Sanso, senior member of IEEE, is a full professor of telecommunication networks with the Department of Electrical Engineering at the École Polytechnique de Montréal and director of LoRe Lab, a research group dedicated to developing methods and for the design and performance of wireless and wireline telecommunication networks. Over her career of more than 25 years, she has received several awards and honors, has published extensively in the telecommunication networks and operational research literature, and has been a consultant for telecommunication operators, equipment and software manufacturers, as well as for mainstream media. So this is a pre-recorded presentation. I will play the video, and now you may start using the Q&A function to interact.
Welcome to my talk about the vertical quality of experience evaluation and prediction in a large-scale 5G network. Imagine that you have an automated system that is working on a 5G network. When a human has a problem with the network, he or she will call the operator. But imagine that you have machines that are working for this automated system. How can a machine call the operator? In fact, when a human calls instead, it is already too late. There is a problem with the quality of experience of the vertical application. Now, what are verticals? I just introduced a word. What is a vertical? So a vertical is a specific market. Like, for instance, intelligent transportation system is a market, electric utilities, another market, healthcare, financing, retail, and so on. The other word that I introduced was quality of experience. So what is quality of experience? So at the end of the day, quality of experience is are you happy or unhappy with your application? This is what it means. Now, the objective of this talk is the overview, the challenges, and the proposed solution, a proposed solution that we have to evaluate vertical quality of experience in 5G networks. This is a list of the challenges, but I would like rather to go through each one of those so that you understand what I'm meaning with this list. The first challenge is the fact that verticals share the same 5G infrastructure. So when you are studying the performance of a particular vertical, you are not considering just the traffic for that vertical. You have to take into account the traffic that comes from all the applications, from all the verticals that are sharing the infrastructure. And this is true even though we have the notion of slicing in 5G. We still have many, many applications of different types that are going to use the same infrastructure. The second challenge is what we call the key performance index. So the key performance index are the performance measurements that we are going to take to see if a particular application is working well or not. Well, the requirements for the key performance index are very different, even within the same vertical. For instance, here we have latency, which is a key performance index that is used all over the place. Even with latency, you have that within ITS, you have different requirements, whether you have vehicle-to-vehicle pre-crashing information, in this case it's 20 milliseconds, or vehicle-to-infrastructure traffic signaling violation warning. This should be done in 100 milliseconds. And the same you can say it for other applications in other verticals. The challenge number 3 is the fact that applications are geographically distributed. They are no longer applications that are confined to just one place in the city and that can be defined by what is happening inside a base station. Sometimes you need different base stations and different elements to act together to have this application. So in this case, I'm showing an example or an application of a bus that has to communicate with a traffic light, and you have several base stations that act together, and we have to take into account the information that is exchanged between all those elements to the control system. The next challenge is the large-scale nature of the system, which is different from the previous one. It's just because it's not just that the application is distributed, is that we also have thousands of base stations in the city, a huge number of user equipment, and very large simulations or data gathering campaigns. So this is not feasible. It's not easy to do in terms of simulation or in terms of data gathering. Challenge number 5 is the multi-layer problem. When we talk about the quality of experience, well, who is the element that is going to have an experience? I mean, is it the network? Is it the user? Is it the owner of the vertical? So this is exactly what we mean as a multi-layer problem, because what is happening at the network level can have an effect on the user and can eventually have an effect on the owner of the vertical. In this example, we still have the example of the bus that has to communicate with the traffic light. If the bus doesn't receive or send the right packets at the right time, there might be some latency in the bus route. So there is a delay in the bus route, and the people that are waiting for the bus are not going to be happy. So at the end of the day, if too many people are not happy, then the owner of the vertical is not happy. And we have to take everything into account if we really have to evaluate the quality of experience of the vertical application. The next challenge is related to the temporal scales. And here we have the very, very different vertical scales. And this is very difficult to simulate, to work with that. We have at the lower level, we are going to be working in millisecond by millisecond. Whereas if we go up to the user level, depending on the application and depending on the vertical, we may be talking about minutes or maybe hours. And then if we go up to the owner of the vertical, we may be talking about days or even weeks. So there is this very different temporal scales must be taken into account when we are evaluating the quality of experience. The next challenge is related to the data granularity. So what happens is that we have too much data. It's impossible to keep all relevant temporal data. It's impossible for an operator to keep all that data. So what operators do, or what should they do? They aggregate information, and they make statistics. Now, the problem to evaluate the KPIs is that those statistics may be too coarse. So maybe if you take statistics every half an hour, it's not enough to detect that something is wrong with a particular system. So data granularity is really another challenge. The last challenge is slice integration. And the problem with slice integration is that we are assuming that slices are beneficial for the quality of experience. But in reality, it all depends on the slicing architecture. So usually people think, okay, we're going to give a slice to a particular vertical. But maybe it would be more interesting from the performance standpoint to use a slice for different applications of different verticals that have the same requirements, for instance, to have two slices for one particular vertical and so on. So there are many combinations that can be done with respect to the right slicing when we are evaluating quality of experience. And this should be done if we really want to optimize the performance of the system. So now let's talk about the solutions. So this is the proposed framework. First of all, this framework is based on an optimization framework. The optimization framework is to optimize the slice provisioning. This is very important. Slices must be provisioned in the right way. Inside this optimization framework, then we have a large simulation and data gathering. We are going to tackle challenge 1, which is the common 5G infrastructure, challenge 2, which is the different KPI performance requirements, and challenge 4, which is the large-scale problem. We must include in this simulation framework the problem of the multi-layer, the challenge 5, which we are going to address it with a vertical co-simulation. So you can see here the overall framework in another way. We have an end-to-end optimization framework that embeds a citywide application system that has a urban subsystem. So we must simulate the urban subsystem, and we must simulate the telecommunication subsystem. And in regards to the telecommunication subsystem, we must take into account the citywide level as well as the cell level. We're going to leverage our current 4G, 5G simulation framework that is available to the public, and you can access it at the web page that is given below. So essentially what we did was we took data from the city of Montreal, data of where elements of the city were located. Elements like the houses, security cameras, the bus stops, the pedestrian crossing, and so on. And we assumed that each one of those elements was going to produce telecommunication traffic for some particular application of some particular vertical. So if besides that, we had the information of where were the antennas of the major cellular providers in the city of Montreal, and so we did these propagation maps with respect to each one of the service providers. Once we did that, then we have this front end and then a back end, which is a simulation back end. In the front end, you can just choose what are the applications that you want to introduce into this simulation, and you can choose how many machines of a particular type do you want, and what is the packet size of the application, what is the arrival of the packets, and so on. And you can also simulate failures. After the simulation is run, then for each one of the KPI, the key performance index, we have a heat map of the city. And we can get into a particular area of the city and see what are the most important KPIs that have been extracted from the simulation. So here, for instance, we are talking about maximum access delay, and you could just zoom in and see what is happening with respect to the maximum access delay. It is not just applications that are local, but as I said, we also deal with challenge number 3, which is the geographically distribution, when you have an application that is geographically distributed. So in this case, we still take the example of the bus that is going through a particular route, and we aggregate the statistic. We keep track of the statistic all over the route to have the final statistics for this application. Now, once we do that, then we must do machine learning to be able to extract information about how the applications for particular verticals are behaving, and also to be able to predict if there is a problem at a particular time with an application. Now, the temporal scale and the data aggregation challenges are really tough. One of the problems we have is that we are simulating millisecond by millisecond, and this is really impossible when you are going to take into account a huge city that is working with 5G. So, as I said, we must first simulate the urban subsystem and see all the activity of this urban subsystem. And then we have to transform that activity into eventually a KPI distribution. So the idea is to simulate and then transform the activity into a KPI distribution. Once we have that distribution, then we have an algorithm to be able to take another condition and see what is the level of the KPI that we have. And finally, we do some aggregation and analysis at the citywide level. And we come back to the urban subsystem, and we study the interactions, the geographical interactions that there are between the different elements of the application. And finally, we extract the vertical quality of experience. What are the perspectives of this framework? Well, first of all, it is a framework that is appropriate for what-if analysis. Second of all, it has a potential use. If you are updating your infrastructure, you could use the framework to see how well this update is going to go. Contingency for catastrophic events, vulnerability to cyber attacks, failure detection, and also as forecasting. As a conclusion, 5G is powerful and is complex and is tailor-made for vertical applications. We have identified and proposed solutions for 8 challenges that we see in the evaluation of quality of experience for those vertical applications in 5G. And it's a comprehensive framework that has advanced optimization, machine learning, and statistical modeling. And I would like to thank, this is a project that has been going on. I would like to thank the current and former colleagues and students that have worked on this project. And here you have a list of publications that have come from this project. Thank you.
Thank you very much. Thank you very much, Brunilde. You might want to activate your audio. Hello?
Hello. Can you listen to me?
I can hear you.
Okay, can you hear me?
Yes, I can hear you very well.
That's good.
So, thank you very much for your presentation. I have a couple of quick questions. So first of all, you talked about a large-scale framework. Can you give us an idea of the numbers, so the order of magnitude of the instances that you use in the framework you presented?
Well, right now we're working. It's just we're working really with the 4G that is going into the 5G. We have around 400 base stations. But if we're talking about 5G, then you have to multiply that by, several, depending on the city, but it can go into, even tens of thousands in the very large cities in China. They have tens of thousands of base stations. So this is very, very difficult. My point is that it is very difficult to assess what is going on in terms of machines when you have this kind of large scale, and at the same time you have distributed applications. As long as the applications they are very local, there's no problem. But when you want to have applications in which machines communicate with other machines, then you have a problem. That's my point.
Yeah, it's always a trade-off between computational issues and let's say fitness to reality, because these systems are large scale by nature.
Yeah, it is more than, I would say that we go beyond computational, because the scale is just too large. It's just, even if we have all the elements right now that we can use, all the computation that we can use, the scale is just too large. So we cannot just go, we cannot just use what I would say like a brute force approach. You know, we cannot just simulate and use a brute force approach. You have to do some more sophisticated modeling to be able to tackle this problem.
And I imagine assumption to simplify the modeling.
And we
Thank you
have
very
to
much.
do assumptions.
Yeah.
Okay.
As we all know. Thank you very much for your presentation. We will be sending questions that are coming via email. And
okay.
Thanks again.
Bye-bye. Thank you.
So this concludes session number 1.